It means, this is definition, it means queue is a collection of items where insertion and deletion can take place in different ends. Front end is responsible for deleting an existing item from the queue, whereas rear end is responsible for inserting an item or element into the queue, right? Then it means this follows, queue follows the principle of first in, first out. Queue follows the principle of first in, first out. As you see in the diagram, the peoples are standing in queue. The peoples are standing in queue, right? The peoples are standing in queue. The person who is standing at the front end, first person in a queue, will finish the process first and he is leave the queue. That's why there are two ends, right? Nodta irtira elle queue idru kuda queue start adaga first person irtane, then first person join ಆಗ್ತಾ ಹೋಗ್ತಾರೆ. ಎಲ್ಲಿಂದ? ಫ್ರಂಟ್ ಕಡೆಯಿಂದ ಇಲ್ಲ, ಬ್ಯಾಕ್ ಇಂದ. ಆ ಪರ್ಸನ್ ಬ್ಯಾಕ್ ಇಂದ ಜಾಯಿನ್ ಆಗ್ತಾ ಹೋಗ್ತಾರೆ, ರೈಟ್? ಅಂದ್ರೆ ಇನ್ಸರ್ಷನ್ ಕ್ಯಾನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಫ್ರಮ್ ದ ರಿಯರ್ ಎಂಡ್, ದಟ್ ಇಸ್ ಬ್ಯಾಕ್ ಎಂಡ್. ಡಿಲೀಷನ್ ಮುಂದಿದ್ದವ್ರು ದಾಟ್ತಾ ಹೋಗ್ತಾರೆ, ಕೆಲಸ ಮುಗಿಸ್ಕೊಂಡು ಹೋಗ್ತಾ ಇರ್ತಾರೆ, ಹಂಗೆ ಅಂದ್ರೆ ಫ್ರಂಟ್ ಎಂಡ್ ಇಂದ ಡಿಲೀಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ಶೋನ್ ಇನ್ ದ ಡಯಾಗ್ರಾಮ್. ದ ಪೀಪಲ್ಸ್ ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇನ್ ಕ್ಯೂ that contains two ends, front and rear. Insertion can take place from the rear end, whereas deletion can take place from the front end. In one more diagram, second diagram also, that is shown clearly. Front and back are the two ends. Then deletion. Deletion can be done from the front end, that we call it as one term called as Dequeue. In queues, for deletion we are calling it as Dequeue. Then for inserting we are calling it as NQ. These are the two new terms we are using in queues, NQ and DQs. NQ means insertion, DQ means deletion. I hope the definition you understood, right, with the help of this diagram also. After that, once we know that what is queue, then we move on to the types of queues. There are different types of queues are available. The number one is called as simple queue. Second one is called as circular queue. Third one is called as priority queue. And last one is called as, fourth one is called as double-ended queue. In short, DQ. D-E-Q-U-E-U-V, DQ. So these are the four different types of queues are available. Then we move with the first one. What do you mean by simple queue? What is the meaning of simple queue? Right? The simple queue. As you see that in the first diagram, the simple queue representation we have done with the help of total 9 elements. This is the array style. This is then array style. So in this total there are 9 elements. 0 to 8. In that, the letter A is at position number 1. It means that is the front. Then letter E, that is in the position 5. Right now we have only A, B, C, D, E elements. It starts from 1, ends with 5. Rear is at 5. That is shown in the diagram, in diagram of simple queue. Right? What is simple queue? Again, if you see the simple queue, a simple queue insertion occurs at the rear end of the list or array, whereas the deletion occurs at the front end of the list. In the diagram, the front is 1, rear is 5. That's why it is called as simple queue or queue. When you observe the second one, circular queue. Circular queue. As we all know that circular means is in the shape of circle. That's why circular shape. You observe the diagram. In this again there are 8 elements are there, 8 data items, 0 to 8. The position 0 contains F item. Then position 8 contains C. Right? So in this, the last element is F. That's why we're calling it as rear. Right? So as we know that in the simple queue, the 8th position element is the last element that is again linked to the first element, right? That is again linked to the first element. That's why it is called as circular. The shape of the queue is circle. That's why it is called as circular queue. The last element is connected to the first element that looks like a circle. That's why it is called as circular queue. A circular queue is a queue in which all nodes or elements are treated as circular, such that the last node follows the first node. The last element or item follows the first element or first node. This is about second type of queue. Then when you go for third type, that is called priority queue. Priority queue. As we all now learned that queue means there are two ends. In the first case, simple queue learned, there are two ends. One is called front, second one is called rear. Right? Front is used for deletion, rear is used for insertion. Based on this knowledge, if you observe the priority queue, then word itself priority means in this queue, the priority may be changed. According to priority, the insertion and deletion can take place. It means in a priority queue, you can insert the item anywhere in the queue. Not as in the case of previous two cases. Only you can insert at the rear. That is not the case here. That's why it is priority. Even deletion can be done with any item. That may be the front item or in the middle. You can delete that also. That's why the word is priority. The best example ಏನು ಅಂದ್ರೆ some queue ನಲ್ಲಿ ನಿಂತಾಗ assume that the common peoples are in queue for something, right? At that time, if someone VIP enters there, right? For VIP, the queue is different. Directly they can enter into the queue as a front element, right? It means they are changing their priority. Common peoples are one priority, VIP persons are another priority. It means the queue will be changed. Correct? ಆ ತರ ಇಲ್ಲಿ priority ಬರ್ತಾ ಇದೆ. Priority queue. The diagram is important. 0, 1, 2 are there, then 30, 11, 99. Some example, they are not constant. You can write any values here, right? So, in the priority queue, it is a queue that contains items that have some preset priority. Preset means already we know where we want to insert, where we want to delete. An element can be inserted or removed from any position depending on some priority. Is it clear? Then, last one, double-ended queue or Dequeue. As the name itself specifies that double-ended, it means two-ended. It means we all know that queue has two ends, front and rear, right? In the up to 3 cases we have learned front is used for deletion, rear is used for insertion. But in double-ended queue, both the ends perform both the operations from both the ends. Either it may be front end or rear end, insertion and deletion can take place. That's why it is called as Dequeue or double-ended queue. It is a queue in which insertion and deletion takes place at both the ends. Right? This is about the types of queues. I hope you got it. Otherwise, you can clear your doubts if you have any doubts.
No, sir. No, sir.
No? Shall I go for next one?
Yes, sir.
Okay. Next heading what we are getting is, again as usual, the operations which we can perform on queues. That is called as queue operations on queue. Operations on queue. These are the operations you can perform on queue. The first one is called as queue. In the case of stack, first one was stack. In the case of queue, the first one is queue. Then second operation, enqueue. In case of stack, it was insertion. In queues, we are calling it as enqueue of item. In stack, deletion was there. In queues, dequeue is there. It means deletion. Then Remaining two are common. Again, that is empty. We are checking the condition, whether the queue is empty or not. Then last one is size. What may be the size of the queue? These are the different operations which we can perform on queues. So we'll go one by one now. What is the meaning of queue? The queue operation. Queue operation creates a new queue that is empty. When the queue is created, if it is a new queue, then by default it is empty only. It needs no parameters and returns an empty queue. That's why inside the brackets nothing is there. Queue of open parenthesis, close parenthesis. It means this does not contain any parameters. Only queue is the operation using which we'll get a new empty queue. Then second one, NQ of item. NQ means insertion. What should be inserted? That is given as item. NQ of item. NQ of item, this operation adds a new item to the rear end of the queue. As we all know that the queue follows first in first out principle. So based on that, the insertion can take place. Addition of new item can takes place from the rear end of the queue. It needs item and returns nothing, because the whatever the item we want to insert, that item will be inserted. In the return, we are not getting anything. This operation is generally called as push. We learned this word in stacks. NQ, insertion, or push. All the three are equivalent meanings. Three are same. You can call it by any way, but better way is, in case of stack, you can call it as push. In case of queue, you can call it as NQ. Then we move on to the third operation, that is Dequeue. Dequeue means it removes the front item from the queue. Dequeue means it removes the front item from the queue. It needs no parameters and returns the item. It is the opposite of NQ. NQ needs some item should be inserted, but whereas Dequeue does not require any item. It only removes the item from the queue. It means we're getting it one item here. It returns some item after removing that particular item from the queue. The queue is modified. This operation is generally called as pop operation. It means three terms you will learn now, right now up to here. One is called deletion. Then you will learn in stacks pop. Now we are learning Dequeue. All the three are equivalent meanings. Insert, deletion, pop, Dequeue. All are same. But in queues, we have to use Dequeue. Then the fourth one is empty. It means this is a condition. We are checking whether the queue is empty or not to perform some operation, right? That's why it tests to see whether the queue is empty. It needs again no parameters and returns a Boolean value. It means if it is empty, we may get the result as 1. 1 means true. If it is not empty, right, we may get the 0. Is empty means we are getting the Boolean values either 0 or 1 as a result from the is empty operation. Then we move on to the last operation called as size. The size returns the number of items in the queue. What may be the size of the present queue? That will be given by the operation called as size. How many number of items are available in a queue? That will be returned by the operation called size. It needs no parameters and returns some integer value. How many elements are there? It counts and returns one integer value as a result by the operation called as size. Any doubt concerned to these operations? Yes, any doubts?
No, sir.
Then can we move on to the next topic? Yesterday question?
Yes, sir.
Yes.
Okay. Okay. The next one. Next one is I just the memory representation of queue using arrays. The memory representation of queue using arrays. How do you learn? What do you mean by memory representation every time? In stack, we have learned, in arrays, we have learned one-dimensional, two-dimensional stacks. Now we are going with queues. Memory representation of a queue using arrays. When you say that using arrays means, we know that all the items or an elements arranged continuously in memory because it is a linear queue. Elements present in queue are stored continuously in memory. Then, if it is concerned to queue means the queue contains two pointers called as front and rear. The pointer front contains the location of the element to be removed or deleted. And the pointer variable rear contains the location of the last element which is inserted. Is it clear? Concerned to that memory representation of queue using arrays? These are common. From beginning you are studying this from arrays. Then the important conditions are, if the condition front equal to null, this we are using algorithms, that's why we are studying here. If the condition front equal to null, what it indicates? It indicates that queue is empty. If the front is null, queue is empty. The same way, opposite way, if rear equal to n or n minus 1, the rear equal to n minus 1, that indicates the queue is full. I hope this theory you understood. Is it clear? All the terms? Is it clear to all?
Yes, sir.
Okay,
Yes, sir.
next you observe the diagram. Again, once again, I'll repeat with the help of the diagrams. Representation, memory representation. When you observe the first diagram, what it contains? The A, B, C, D are the elements or data items in a queue. It is simple queue, right? Then front is A, because the first element is A. Already 0th position is removed. Right now we have in this array only 4 data items or elements in this queue. That's why the front has taken its position as 1. Then you observe the last element is D, last item. That's why rear is at position number 4. By this reference, we are writing front equal to 1, rear equal to 4. Is it clear? Then,
Yes, sir. Yes,
then
sir.
if you want to insert an item into the queue, you have to increment rear by 1. You have to increment the rear by 1. It means rear equal to rear plus 1 you have to use. Rear equal to rear plus 1. If you observe the first diagram, the rear is at 4. If you increment the rear by 1, that becomes 4 plus 1, 5. Right? It means rear has reached the position number 5. Right now that is empty. Then you can perform the NQ operation, that is insert operation from the rear end, so that the element or item E is positioned at number 5. That is shown in diagram number 2. Understood the second one? In case of stack, to insert an item into the stack, we are incrementing top by 1, as you all know that. In the same way, in queues, if you want to insert, that is called as NQ, into the queue, then you have to increment the rear pointer by 1, so that you'll get the new empty space. There you can insert a new item into the queue. This is the procedure in queue insertion. That is shown in diagram number 2. Understood this? NQ?
Yes, sir.
Yes,
Then
sir.
reverse process will study. The diagram number 3 indicates pop operation. DQ operation we are showing. If you want to remove an item from queue, or in the queue A, B, C, D, E are there. A is at position 1, E is at position 5. Now I want to remove an item from a queue. As we all know that the DQ operation takes place from the front end. DQ operation takes place from the front end. How to remove that? Front end is A. We want to remove A from the diagram number 2. How to remove that? Just by incrementing the front by 1. Just by incrementing the front pointer by 1, the current item can be dequeued or popped from the queue. That is shown in diagram number 3. It has front has taken position 2. Previously it was at position 1 in diagram number 2. Then increment the front by 1. Front equal to front plus 1. 1 plus 1 is 2. The front has reached position 2. It means the A is deleted from the queue. This is shown in diagram number 3. This is all about memory representation of queue using arrays. One technique it is, one way, using arrays. So I need to concern to know this complete technique. Anybody is having doubt?
No, sir.
Okay. Next one. The second method of memory representation of queue, that is called as memory representation of queue using linked list. Using linked list. In linked list, we are familiar now. Linked list contains nodes. Instead of items, we are calling it as nodes. Nodes contains items here. So nodes, that term we are using. Already you are familiar in stacks, that particular linked list term. So queue is also represented using linked list. As in the case of stack also we have learned. Here also same thing you can proceed. In queues, an item should be inserted from the rear end and an item should be removed from the front end. Nothing is new, same thing. The pointer front contains the location of the first node of the linked list and the pointer rear contains the location of the last node of the linked list. Everything is same. Instead of item we are using here node. Understood this concept? Instead of item we are using a term called as node in the case of linked list, and the diagram changes. Instead of one box, now to go with 2 blocks of each node. So if you observe the first diagram of linked list, memory representation of queue using linked list, you observe that starting point you are calling it as head. Then the first item, in this case linked list we are calling it as node. The first node, that is the front. The item 50 is stored there. Item 50 is stored, that is front. This linked list diagram contains 3 nodes. Node 1 is 50, node 2 is 25, node 3 is 20. This is the third node, right? When you observe the third node's second box, that are calling it as link field. Already I have discussed this. In each node, a node is divided into 2 parts. Node is divided into 2 parts. First part is called as data field. Second part is called as link field. It means data field contains some values, whereas link field contains, it connects to the next node. The link field contains the address of the next node. That's why that we have shown with the help of arrows in the diagrams. When you observe like that, the last node link field is null. Last field, link field should contain null. Either you can write it as null or backslash also can be used. That we use in case of stacks. Here writing straight away null. Then last node's link field contains null. It means this is the last node of the linked list, or else end of linked list. I hope you understood the first diagram. First diagram is linked list, right? That contains 3 nodes. The front node is 50, rear node is 20. Yes? Any doubt? Is it clear? First diagram.
Sir,
Yes, sir.
Because somebody is disturbing. Girls ಅಲ್ಲಿ ಯಾರೋ ಮಾತಾಡಿದ್ರು ಅದಕ್ಕೆ ಡಿಸ್ಟರ್ಬ್ ಆಗ್ತಾ ಇದೆ ನೋಡಿ. Maintain discipline and listen. Nothing is there. If you are observing the diagram, observe the first diagram. This representation is called as linked list. Why it is called as linked list? Because linked list contains nodes. Each node is having 2 parts. First part is called as data field. Second part is called as link field. When you are observing the first diagram, the value 50 is in data field. One dot is there. From there we are drawing the arrow. That is called as link field. We are linking first node to the second node. Always the link field contains the address of the next node. Then, as per this information, this linked list contains 3 nodes, 50, 25 and 20. 50 is front node, 20 is rear node. The rear node link field contains null because that indicates end of linked list. Is it clear now? Shall I go for next diagram?
Yes, sir.
Okay. Next you can learn. The second diagram is showing that how to insert, how to enqueue an item into the linked list. As we all know that common, the insertion can take place from the rear end. The insertion takes place from the rear end. It means the second diagram indicates that the addition of node has taken place. They have added one new node called as 75. That node 75. First you have to create a node. First you have to create one node. Then you can connect to the last node of the linked list. Only change is the null. The link field value changes. Previously in the third node, null was there. That is shifted to newly inserted node. Link field contains null. It means this 75 is inserted into the linked list. This is a dynamic process. Linked list is dynamic process. As you learned in case of stacks, also differentiated that array versus linked list. This is dynamic. You go on adding new nodes into the linked list. And in the last one, we are showing that the deletion operation, dequeue operation. As we all know that deletion or dequeue in a queue takes place from the front end. Front end. How it works? Again, increment the front by 1. Increment the front by 1. Or else one more option is directly. As we know that there is a head here. When you observe all the diagrams, head contains always the address of the first node. Head contains the address of the first node. If you make changes in the head, instead of that 50, directly you can give address of the second node in the head. Automatically, the first node will be deleted. That is shown here in the third diagram. Directly from the head, we are connecting to the item number, that is item value 25. Previously, it was the second node. Nowadays, the first node in the linked list. It means the value 50 is removed from the front end of the queue. This is about the memory representation of queue using linked list. Now, do you have any doubt concerned to these? You can ask. Any doubts? Concerned to this, any doubts? Are you listening? ಕೇಳಿಸ್ತಾ ಇದೆ ನಾನು ಮಾತಾಡ್ತಾ ಇರೋದ್ರಿ?
Yes, sir.
Any doubts?
Yes, sir.
Concerned to queue?
No, sir.
No, sir. No.
No, sir.
No, sir.
Again, no means we'll complete today. Instead of that algorithm, we'll go with tomorrow. We'll take that algorithm, insertion and deletion. Today you can go through the procedure what you learned in case of stacks. Take an example and perform insertion and deletion operation by incrementing front and rears. Just once you can practice at home, so that tomorrow we'll complete the algorithm of that too. Now we'll go with the next heading called as the applications of queues. Applications of queues.
Sir, there is only 1 minute.
The first application is, yes, pardon?
There's only 1 minute left out, sir.
1 minute, na?
Yes, sir.
That's why I'm going with queues, right? Purposely I'm skipping that. There is no time today. We cannot complete that. That's why I'm going with applications, so that at least 1 or 2 features can be completed. Right? Clear?
Yes, sir.
Okay. Now listen. The applications of queues. The first application is called simulation. It works like, simulation means it works like a queue. Already we have learned queue. In general things also, day-to-day life queue is there. In the same way, this also a queue. It is implementing according to the general sentence queue. That we are calling as simulation. It works like that, general queue. These queues are used mainly in operating systems. Operating systems.